As you can see, indices is actually easy, very easy. And when you're doing is indices, you just need to remember the law. You apply the law whenever you have a question, whether it is a kind of algebraic indices or a plain indices, as we have some of them on the board. And do not forget that indices also is related to kind of to algebra. In fact, algebra is the key in most math topics. Very key. So now we're going to solve these three questions, and I think they are quite selected for indices. And please, if you need more questions, you search online for questions, or you chat the number displayed on your screen for more questions in case you want it. I will actually send some questions I can practice with on indices, and you send the answer to me for correction. So now let's solve these questions, and you can see that what do to we have here is just a plain division law of indices. So what we do first is that we divide these two. So that is going to be 12 divided by 4 in brackets, and we have that in bracket. So then we have our exponents one after the other. So that's a raised to power 5 minus 2. So do not forget its division. Numerator comes first, into b raised to power 4 minus 1. Minus 1. So why do we do it that way? So numerator comes first when you are dividing. Do not forget that is the division law of indices. So this is going to give us 3. So that becomes 3. And our exponent here, that will be a raised to power 3. A raised to power 3. Yes, that's 5 take away 2. And b raised to power 3. And at this stage, this becomes our final answer. Very easy to do, very easy to solve indices. And if you check this very well, that is like the product of products. And also we have this 4. So the exponent here is working for both 4 and a. So meaning that we need to put this our a exponent 4 and in brackets to be matched with another bracket which is going to be our a exponent 3 and 4. So if you use the product of products rule, then you see that these two can be multiplied. When you have something like that, you multiply them. So this will be 4 exponent 4. I believe that should give us 216 or something. So now let's do the math. So 4 times 4, 16 times 4, 64. 64 times 4, that's 16, that's 24. 256, I think. Yes, 256. So that gives us 256 and a exponent. You multiply these two, a exponent 12. So that is our final answer for this. So for the next one, you will see that there is a negative power there, and also we have the fractional power. So a negative power and a fractional power. So that automatically becomes 1 over 27. Okay. So this becomes the root. Okay. The root, cube root, and this 2 becomes the exponent. This 2 becomes the exponent. So this is what we have. So that will be 1 on the cube root of 27 square. So you find the cube root first. So that becomes 1 over that cube root, that should be 3. 3 square. And 3 square is going to be 9. That becomes 1 over 9. Final result. Final result for that. So indices is very easy. Try to solve more questions, and we're going to look at the one that we're going to eliminate the base. So that means we make the base to be equal and eliminate the base in order to solve it. So in our next video. So thank you for watching. Please subscribe. So we're looking at unknown power here. So in case you want to solve this, you actually need lots of indices as well. And of course, you need your number, understanding of your number, your square root, cube root, to be able to solve this as well. So in case you've not subscribed to my channel, please subscribe and like the video. So now let's continue with this. So in this case, we are looking for the x. We are finding the x in all of them. So and the x is unknown. So this is number 1, 2, and 3. So The x is unknown. So to find the unknown, we have to give them the same power. We express this according to the power of the exponent. So we make sure that the base, which is 2, are equal these two. So we express this as the power of 2. So if you want to express that, that should be 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. So that's 2 exponent 5, right? So that is going to be 2 exponent x is equal to 2 exponent 5. 2 exponent 5. So in this case, we eliminate the exponent, 2 cancel 2. Then our x will be equal to 5. So this is how to solve when you have your exponent to be unknown. So the same thing we did here, we're going to do the same thing here. So where we have, so we make this to the power of 5, we make this base to the power of 5. So you can see since our base here is 5. So that means we have 5 exponent x is equal to 5 exponent 3. So that should be 5 times 5 times 5. So 5 times 5 times 5 gives that, right? So then at this stage you eliminate the 5s, then your x is equal to 3. Final result. So the last one, to do that, you express this to be exponent of 4. That should be 4 times 4, 16. 16 times 4, 64. So that should be 3 raised to power 3. So we have 4 exponent x plus 1 is equal to 4 exponent 3. And in the same manner, we eliminate the 4's. 4 cancel 4. So that means we now have our x plus 1 is equal to 3. And do not forget, we are looking for the x. We are not looking for x plus 1 is equal to 3. So that means this 1 is going to travel to this side. We collect the like terms. So that becomes x is equal to 3 minus 1. And our x will be equal to 2. Our x will be equal to 2. So thank you for watching. Please subscribe and do not forget to practice more videos to solidify your understanding on indices.